Hey there, this is Dr. Mort Orman, and I want to continue our conversation today about the relationship between science and stress. And part of the reason why I'm doing this series this week is because, we're constantly bombarded with scientific information. And it's presented to us as if it's communicating to us truths about life that are discovered through science. So I wanted you to get a little bit more of an understanding of some of the underbelly of science and some of the difficulties with science that most people don't appreciate, that make you really take a lot of this scientific data that's being thrown at us, or scientific conclusions that are being thrown at us, with a sizable grain of salt. So the point I want to focus on today is how science has blind spots. Now, we talked a while back about all different kinds of blind spots that human beings have. But it's interesting that science itself has blind spots, and not just because science is conducted by human beings, but science itself, the actual structure of science, is built in such a way and is dependent on its existence in such a way that it naturally embodies certain blind spots that can never be overcome, that are just part and parcel of doing scientific research. And the main reason for this is because science essentially works best with things that are tangible, with things that are observable, with things that are measurable. And if you meet those three criteria, you can generally do good scientific studies, because that's what you really need. You need to be able to measure things, observe things, create experiments, see outcomes, and all of that has to be tangible stuff that's quantifiable, measurable, and then you can do good scientific studies. Science doesn't do very well with items or aspects of life that don't meet those criteria, that are not tangible, but are very real and very important in many instances, particularly when you're trying to do science on human beings. And that's because science can't do very much with things like love or commitment or courage or creativity. These are all things that are not tangible, but they can be very important and can make a huge difference between human beings, how those qualities are developed in a person and expressed in a person, that can affect outcomes of lots of different kinds of studies that you might want to consider to try to understand human life. So science has those blind spots naturally built into it. And we have to take that into consideration. So we talked in the last video about how scientific data can be, and studies can be manipulated, in that you might not always be getting the whole story, because there may be lots of studies out there that favor a particular point of view, but there could be many, many other studies that have been done on that same topic that would contradict that point of view, or would throw question about the conclusions of that other body of information. So you won't be getting the whole story in that sense. But even when you look at a pure scientific study, particularly when it comes to human beings, you have to recognize you're not getting the whole story there either. There are blind spots that are inherent in science, that you're going to miss certain qualities or certain components of the equation of whatever you're studying that are not going to be included in the study. So a good example would be like human communications. If you're studying human communication scientifically, what you can do is you can have two people communicate, and you can take a tape recorder and you can measure, you can record the conversation, and then you can transcribe it. And now you've got a transcript, word for word, of exactly what was said and what wasn't said. And that's objective, that's measurable, that's observable, that's tangible. And you can say, okay, now I'm going to study that, and I'm going to draw inferences about human communication. Well, guess what? You just eliminated 80% of human communication from your study set, because there's so many more things that go into communication than just the words that are being spoken. There's the facial expressions, there's the body language, there's the tone of voice, there's the whole history of interactions in that relationship between those two people that come into play. There's the history of communication in each of those persons' historical lives that come into. There's so many factors that are intangible, unobserved. Well, they can be observed, but they're not easily measured, and they get left out of a study if that's all you do is you boil it down to what you can tangibly, what you can record or write down on paper, or just the words for communication. So that's an example of of the consequences of having blind spots. You would miss a lot of the action, and you would draw probably incorrect inferences if that's all you were studying. Another good example, even with things that are not human in nature. So I saw a TED Talk recently that was done in February of 2016, and it was about a NASA project, a multi-year NASA project to find new planets in a particular region of the universe. And NASA developed these sophisticated computer models that could detect light signals coming from this quadrant in the sky, and they were looking for areas where the light would be blocked out because a planet would come in front of a particular star, and the light from that star would be blocked out by the planet, and that's how they would detect the presence of planets that hadn't been discovered before. They built this enormously complex computer. Okay, and then a bunch of people at Yale came up with the question. So, well, what if this computer has blind spots? What if it misses stuff? What if it isn't seeing the whole picture? So they enrolled a whole group of citizen scientists who were already, sort of a closet astronomers who were already studying the sky, and they trained them on that same area. And they asked them to do the same kind of research just with their natural observing capability as a human being. And guess what? They found planets that the computer model from NASA completely missed, because the computer model had a sophisticated algorithm, but there were certain things they didn't anticipate, certain actual events in the universe that they had no idea about, that they didn't build into their algorithm, and therefore they didn't get any positive signals when those things occurred. But a human being looking at it, even an amateur astronomer, was able to pick up some of these phenomena that the computer completely missed. So that sophisticated computer that NASA built, that they thought had it all covered, had blind spots. And that's what I'm talking about in science in general. There's always likely to be blind spots, which is why you need to be very, very critical in your thinking when you're listening to scientific information. And we'll talk tomorrow about, again, getting back to when you're studying human beings and you're doing science on human beings, the number of blind spots and the size of the blind spots that get involved and corrupt the conclusions and cause all kinds of problems in being able to really understand what's going on can be enormous. So we'll talk about that tomorrow.